aLGeBRa. Hello. Hey, look, we're missing you guys. This term we're going to start with aLGeBRa. We will be doing aLGeBRa just for week 1 of term 2. We need some of the skills from aLGeBRa in measurement, which we're doing this term. We would normally be doing aLGeBRa this term, but because we feel like it's a little bit more of a tricky subject, we'll move to something that's a bit easier for you guys to do by yourselves at home. We always get asked, why? Why do we have to study aLGeBRa? You use aLGeBRa all day, every day in your lives, okay? If you have Sarah Jane's cat that she always draws on the board and she wants to sell her cat on Facebook for $27 is the price of Sarah's cat. And someone sends her a message saying, do you ever drive past Port Arthur? What is your lowest price? But eventually she does come across a normal person who wants to buy her cat, and they arrive to buy her cat with a $50 note. Now, Sarah Jane can figure out that 27 plus whatever that number is going to equal $50. All right, so that's basic algebra when you look at it like that. And instead of having a question mark, we put in a little X or a P or a Q or a Y or a Z, and that's algebra. Sarah Jane figures out that it's going to cost, she's going to need to get $23 change, and she has used algebra in her everyday life. When you throw a piece of rubbish into the bin, and you get it in, okay, you are figuring out weight, trajectory, force, all of that kind of stuff in your mind. And if you don't get it in and you have another go, then you alter the force and that kind of thing to make sure it does get in the second time. A dog can do algebra, catching a frisbee at the park. You can do it too. Converting things, so like if you're cooking and you're changing like pounds to kilos or Celsius and Fahrenheit and that kind of stuff, you're doing algebra. When a painter wants to paint a room and he looks at the space in the room and how much paint he needs for that space, he's doing algebra. So it's everywhere all the time, all right? And it's just basically patterns. When you looked at algebra last year, you would have looked at your input and output tables and some stuff like that. One of the things you need to remember with algebra, here we go, is to make sure you do your curly loopy X's, okay? This is too much like multiplication. And like we talked about with our Sarah Jane's cat example, it doesn't matter what symbol you've got there. It could be a question mark, it could be a smiley face, it could be an S, it could be a strange duck, it could be a little symbol, okay? When they use letters, they are usually lowercase letters though. So that's what we do with algebra. Here's another important thing to remember. Maybe you can see it. So with algebra, when we've got 2 times t, we write 2t. We don't bother to put in the times. When you've got t plus 2, that's what it looks like. You don't change that in any way, okay? So that's really important to remember. If I've got 4q, all right, that means 4 times q. Now, the first thing we do in algebra is look at variables, okay? So if we talk about maybe our classroom, you're not here. So I don't know, I can't just count how many people there are in our classroom. So I'm going to call our classroom by a certain letter, okay? So let's say we're going to call our class Q, all right? If 5 students move away from our class and go to a class with a nicer teacher, that expression would look like Q minus 5. If we have our class doubled, most of you would instinctively want to say 2 times Q, but remember what we said before, it would be 2Q, okay? If we get 15 new students, okay, it would be Q plus 15. If another class had 7 students more than us, all right, again, Q plus 7. If I saw something that said Q plus 3. Okay, we could guarantee that that class had 3 people more than us. If it had Q minus 3, that means they've got 3 less than us, all right? Where you've got Q over 2, like a fraction, okay, we don't really use divide in algebra. We prefer to put it like a fraction style. So if I've got Q over 2, obviously that means Q divided by 2. If I have Q over 6, okay, that means Q divided by 6. And if we're talking about our class again and it was Q over 6, it would mean we would have 1/6 of that class. All right. Hopefully that makes sense to you guys. There is a using variables PDF. It's got 8.2 at the top of the page. And there's an example looking at ants. So if you want to pause this video, then you can have a go at it. And then I'll go through the question with you in a tick. Pause. All right, good pausing. So the questions here, I'll read them out. Write an expression for the number of ants in the nest if 420 ants were born, okay? It says at the top of the question, we're going to use X to represent the number of ants in a nest. I'll try and get you to have a look here. So we're going to have X plus 420 ants were born. I really hope you can see that because I can't see what you see. 1B, the question is, write an expression for the number of ants in the nest if the original ant population doubled. So obviously we're looking at timesing by 2, and remember what we talked about before, we don't write times 2, it would be 2x because the original population we're calling x. 1C, write an expression for the number of ants in the nest if the original ant population decreased by 130. So that means we would have our original population, x, curly x, minus 130. What would it mean if we said a nearby nest had x plus 60 ants? Well, you guessed it, they have got 60 more ants than x, the nest. E, what would it mean if we said a nearby nest had x minus 90 ants? Oh my goodness, they're still doing this.
Good morning.
Wow.
Anybody who's wanting any
I'm going to turn off now. Bye.